Welcome to MAT115. This is just onto the whiteboard. Oops, I need this one. Make it big. Send this over. I need to get my pencil. All right, what you're going to see here in just a minute is I'm going to be able to write right here. So we welcome to MAT115. Okay, now you'll hear me, and I think you can see me, and then you'll be seeing the whiteboard, and I'll be doing and explaining everything you need to know. And right now, this is the first one, so we're going to do 8.1. Okay, 8.1, I need to refresh your memory. It deals with square roots, cube roots, fourth roots, etc., etc. Now, this number right here is called the index. It's the root. This is looking for the third root or the cube root. Okay. Now, if it just said this and there's nothing there, we can assume it's 2 its square root. Okay. But after 2, the number goes there, and it's cube root, fourth root, etc. Now, I'm not going to worry about this one. I'm going to worry about this one. The cube root of 64 is 4. And I'll tell you why. Because 4 times 4 times 4, or 4 cubed, is 64. Okay? The cubed root of 125 would be 5. Why? Because 5 times 5 times 5 equals 125. The fourth root of 16 is 2. Because 2 times 2 times 2 times 2 equals 16. 2 4 times. Okay, and I'm going to show you one more. What if I had the cubed root of 8 over 27? Remember, you can separate it. So it's the cubed root of 8 over the cubed root of 27. So the cubed root of 8 is 2, because 2 times 2 times 2 is 8. And the cubed root of 27 is 3, because 3 times 3 times 3 is 27. Okay? Now, those are basic ones. We're going to get into a little bit more detailed. Okay? There's 2 formulas I need you to remember. Okay? I need you to remember whatever this index number is, the base is raised to the same amount. Okay? If, in this one, if n is positive, then the answer is the absolute value of whatever a is. If n is negative, then the answer is just a. So for instance, if I had the 6th root of negative 3 to the 6th power, is n positive? I'm sorry, not positive. So. If n is even, and if n is odd. So sorry. N, in this case, is 6. Is that an even number? Yes, it is. If it's an even number, then we take the absolute value of whatever a is, which in this case was negative 3. So my answer would be 3. If I had the 5th root of negative 6 to the 5th power, now n is odd. So because it's odd, we don't do the absolute value. We take it exactly the way it is. And my answer is negative 6. Okay? All right. Let's look at another one. What if I had the 4th root of negative 9 to the 4th power? Even root, so it's the absolute value of negative 9, which is 9. What if, though, I put a negative sign on the outside? Well, now it's the opposite of the absolute value of negative 9, which is negative 9. So be careful if they put something on the outside. That's the additive inverse. which is something you learned in 095. Okay? Now, what if I have this? I have the square root of m to the 4th. The answer is m to the 2nd. I'm going to show you because I could say that's m squared times m squared. When multiplying, you add exponents, so m squared times m squared is m to the 4th. But the easier way to look at it is, what's that number? That number there is a 2, because it's a square root. Divide that into that. 2 into 4 goes twice, so it's m squared. Look at another one. If I had 3, the cubed root of a to the 12th. 3 goes into 12 4 times. That's your answer. If I had the 4th root of x to the 12th. 4 goes into 12 3 times. That's your answer. Okay? Simple, simple, simple. All right. Oh. That's all of 8.1. All right? That's all of 8.1. I'm going to go ahead and do 8.2 right now with it. Okay? So now let's do 8.2. 8.2 now talks about if you have a number and it's raised to a power but it's a fraction, the denominator of the fraction is your index of a square root. The a is in here, and the numerator is what it's raised to. Okay. So, for instance, if I had 4 to the 1/2, that means I'm looking for the square root of 4 raised to its first power. Well, what is the square root of 4? 2. And what's 2 to the first power? 2. If I had 8 to the 1/3, that would be the cubed root of 8 raised to the first power, and the cubed root of 8 is 2, and 2 to the first power. In this case, the answer is 2 again. Okay, what if I had negative 32 raised to the 1/5? That means the 5th root of negative 32 raised to the first power. You got to think back. Can I take the 5th root of a negative number? Remember, the rules were you can take odd roots of negative numbers. You cannot take even roots of negative numbers. So I can. Okay, the 5th root of negative 32 would be negative 2 raised to the first power, which is still negative 2. But if I had something like negative 256 to the 1/4, this is not a real number because I cannot take, because what's going to happen is going to be the 4th root of negative 256 raised to the first power, and I cannot take an even root of a negative number. So the answer is not a real number. Okay? All right, let's go a little bit further. What if I had 36 to the 2/3? Okay. So what root is it? The denominator tells you. So it's the cubed root of 36 raised to the 2nd power. Okay, what is the cubed root of 36? Oops, did I write that wrong? I did. There is no cubed root of 36. Sorry, it should have been 36 to the 3/2. Sorry. So that's the square root of 36 raised to the 3rd power. Root, what's raised? So that means, what is the square root of 36? 6, and it's raised to the 3rd power. So 6 times 6 is 36 times 6 is 18. Hang on. 36 times 6 is 216. 216. Let's try another one. Oh my goodness, can anybody? Hang on just 1 second, please. Yes, Debbie? Honestly, I would prefer one that's 2012, but whatever you want to do is fine. All right, thank you. Bye. All right, so sorry. I'm back. All right, let's try another one. Let's try 125 raised to the 2/3. Okay, that means the cubed root of 125 to the second power. What is the cubed root of 125? 5. And what is 5 squared? 25. All right, let's try another one. Let's try -4 to the 5/2. Now, this is where it gets tricky. This does not include the negative. If it included the negative, it would be like this. It would mean -4 to the 5/2. But that's not what they did. They did not include the negative. This means the opposite of 4 to the 5/2. With that said, it's the opposite of the square root of 4 raised to the 5th power. So the opposite of that, what is the square root of 4? 2. What is 2 to the 5th power? 32. And what's the opposite of it? -32. All right, what if I had this? What if I had -27, but it's in parentheses, raised to the 2/3? Now that means the cubed root of -27 and then squared. I can take the cubed root of a negative number. What is the cubed root of -27? -3. And what is -3 squared? 9. All right. What if I had this? 16 to the -3/4. Now the exponent is negative. And you got to remember back in 095, if you have a negative exponent, it has to move down. In other words, right now it's in the numerator. It has to move down. So it becomes 16 to the +3/4. And with nothing left up top, you have a 1. So this means 1 over the 4th root of 16 raised to the 3rd power. So that's 1 over what? What is the 4th root of 16? 2. And what is 2 to the 3rd power? 8. Let's try another one like that. What if I had 25 to the -3/2? Right now it's there, so it becomes 1 over, because the negative exponent has to go down, 25, and it becomes +3/2, which means it's 1 over the square root of 25 cubed. Now, the square root of 25 is 5, and 5 cubed is 125. So that's your answer. Okay? All right, and one more they might give you. Looks like this. What if I had 8 over 27 raised to the -2/3? Well, if you remember, you distribute it to each piece. Okay? Now, this is negative, so it has to go down. This is negative, so it has to go up. So I get 27 to the 2/3 over 8 to the 2/3. Okay? Which means the cubed root of 27 squared over the cubed root of 8 squared. take a look at that for a minute. Make sure you got it. All right, what is the cube root of 27 in the numerator? The cube root of 27 is 3. And what is the cube root of 8? 2. 3 squared is 9, and 2 squared is 4. And there's your answer. Okay. All right. Next whiteboard. They're going to ask you just to convert. If I had 13, sorry, let's erase that. Erase it off. Okay, if I had 13 to the 1/2, that means the square root of 13 to the first power, or the square root of 13. 9m to the 5/8. Now notice the 5/8 is with the m, not with the 9. So you have 9, and then you have the 8th root of m raised to the 5th power. Okay? All they want you to do is convert. I don't know what the 8th root of m is to the 5th power, so nothing else I can do. They just want you to convert. They're going to have you practice a little bit of the conversion. Then we get into the big stuff. Okay? 2 to the 1/2 times 2 to the 1/4. All right, our base is the same, yes. When bases are the same and you're multiplying, you add exponents. So I really have 2 to the 1/2 plus 1/4. And you're going to have to go back to elementary and remember how to add fractions. If we have to add 1/2 plus 1/4, they have to have the same denominator. And the common denominator would be 4. That one wouldn't change. To go from 2 to 4, I multiplied by 2. So I multiply the top by 2, and I get 2/4. So now what is 2/4 plus 1/4? 2 to the 3/4. You can leave it like that unless they say convert it. And converting it, it would be the 4th root of 2 cubed. Either way. Okay? All right. Let's go a little bit farther. What if I had, oh, here, let's look at, let's do one more easier one. What if I had 5 to the 2/3 over 5 to the 7/3? Remember, when dividing, you subtract. So if I have 2/3 on top and 7/3 on the bottom, I am going to have 5/3 left with nothing on the top. So there's your answer. All right, let's go a little bit farther and let's make it a little bit bigger. What if I had x to the 1/2, y to the 2/3 raised to the 4th power over y? All right, we have to get rid of parentheses. And the way you get rid of parentheses is you distribute. Remember, when you're raising powers, you multiply. So I need to multiply this. 1/2 times 4 is 2. And 2/3 times 4 is 8/3 all over y. Now, I cannot do anything with the x and y on the top. They're two different things. But I have a y on top and the y on the bottom, so I need to reduce those. Well, right now this is 1, but I'm working with thirds. So I'm going to change it to y to the 3/3, right? Because is that the same as 1? Now, 8/3 minus 3/3 is what? 5/3. And there's my answer. Okay? All right, let's try 2 more. What if I had x to the 4th, y to the -6 over x to the -2, y to the 1/3, and it's all raised to the -2/3. Well, the first thing we do is we get rid of parentheses, and we're raising powers, so that means each one of these exponents needs to be multiplied by -2/3. So x 4 over 1 times -2/3 gives me -8/3. -6 over 1 times -2/3 gives me positive 12/4. -2 over 1 times -2/3 gives me positive 4/3. And 1 over 3 times negative 2 over 3 gives me negative 2/9. Now, where do I have negatives? Right here and right here. So this has to come down and this has to come up. That would be the next thing you do is you get rid of the negatives. Okay? So on the top, the y to the 12/4 stays, and I bring up the y to the 2/9. On the bottom, the x to the 4/3 stays, and I bring down the x to the 8/3. Now, 2 y's on top, 2 x's on the bottom. They're being multiplied. When multiplying, you add exponents. So let's add the bottoms. Those are going to be easy. What's 4/3 and 8/3? You get 12/3, which is just 4. But on the top here, we need to convert. But now, is this 3? Yes. So I have 3 plus 2/9. Well, I need to change to a common denominator. So the 9ths will stay, but this one. Okay, to go from 1 to 9, I multiply by 9, so I multiply the top by 9, I get 27. Now, what do I have? Y to the 29/9. And believe it or not, that's your answer. Okay? All right, let's look at one more. What if I had m to the 3/4 times m to the 5/4 minus m to the 1/4? This is the distributive property. We're multiplying. When multiplying, same bases, you add exponents. So I get m to the, what's 3/4 plus 5/4? 8/4 minus m to the, what's 3/4 plus 1/4? 4/4. So that's m squared, 8 over 4, minus m to the first power, 4 over 4. And that's as far as you go. Okay, you're going to have to pull out that out of the mothballs of your mind, everything that has to do with fractions. And remember all the rules for powers. When multiplying, you add. When dividing, you subtract. And when raising powers, you multiply. Negative exponents have to move. If they're on top, they go to the bottom. If they're on the bottom, they go to the top. And there you go. That's it. That's the whole thing. Okay? All right. We are done. Look for the next 2 sections. I'll be doing those soon.